Memory devices. The memory devices are very important part in the embedded systems. So here this internal organic system memory device is shown in the figure. So the address are calculated by this memory array. Then this using this address calculation, the particular data is derived from the memory array. So memories are divided into several classifications. One of this is random access memory. The random access memories can be both read and written. They are called random access because unlike magnetic disk, addresses can be read in any order. Most bulk memory in modern systems is dynamic RAM, that is called DRAM. The DRAM is very dense. It does, however, require that its value be refreshed periodically since the values inside the memory cells decay over time. The dominant form of dynamic RAM is today the synchronous DRAMs, SDRAMs, which uses clocks to improve DRAM performance. The SDRAMs use row address select, that is RAS, and column address select, CAS signals to break the address into two parts, which select the proper row and column in the raw array. Signal transition related to the SDRAM clock, which allows the internal SDRAM operations to be pipelined. The SIMs and DIMMs memory for PCs is generally purchased as single inline memory modules or double inline memory modules. The SIM and DIMM is a small circuit board that fits into standard memory socket. A DIMM has two sets of leads compared to the SIM's one. Memory chips are soldered to the circuit board to supply the desired memory. The next one is read-only memories. Read-only memories are pre-programmed with the fixed data. They are very useful in embedded systems since a great deal of the code and paragraphs of the data does change over time. The read-only memories are also less sensitive to radiation interaction error. There are several varieties of ROM available. First one is masked program ROM. The ROMs can typically be ordered in a lot of few thousands, but clearly factory programming is useful when only when the ROMs are to be installed in some quantity. Next one is I/O devices. The most important I/O is timers and counters. This is the watchdog timers diagram. The watchdog timer is used to support the CPU without locking indefinite loop. The next one is A2D and D2A converters. Analog to digital and digital to analog converters used to interface non-digital devices to embedded systems. The ADE conversion requires sampling the analog input before converting to digital form. A control signal causes A2D converter to take a sample in digital stage. There are several different types of A2D circuits, some of which takes constant amount of time, while the conversion time of other depends on the sampled value. The variable voltage conversion provides done signal so that the microprocessor knows when the value is ready. A typical A2D interface has, in addition to its analog inputs, two major digital inputs. The D2A conversion is relatively simple, so the D2A conversion interface generally includes only one data value. The input value is continuously converted to the analog form. The next one is keyboard. The keyboard is basically an array of switches, but it may be include some internal logic to help simplify the interface to the microprocessor. In this chapter, we build our understanding from single switch to a microprocessor control keyboard. So in this keyboard, there is one problem called as keyboard switch dependency. So there is a group of pulse generated by pressing a key in a single time. So this switch bouncing is avoided by using the key debouncing algorithm. The scanned key array diagram is shown in figure. The next one is LEDs. The electromagnetic diodes are often used as simple displays by themselves. The resistor is connected between the output pin and the LED to absorb the voltage between the digital output voltage and 0.7 volt drop across the LED. When the digital input goes to 0, the LED voltage is the device off region and the LED is not on position. So this is the circuit diagram for interfacing the LED with the digital output. So this is the n-bit digital display. The next one device is touch screen. The touch screen is an input device overlaid an output device. The touch screen resists position of the touch to its surface. By overlaying this touch display, the user can react to information shown on the display. The two most common type of touch screens are resistive and capacitive. Resistive touch screens uses dual-dimensional voltmeter to sense the position. The top conductive sheet is flexible, though it can be pressed to touch the bottom sheet. The voltage applied across the sheet is resistance causes the voltage gradient to appear across the sheet. The top sheet samples the conductive sheet's applied voltage at the contact point. The analog digital is used to measure the voltage at the resulting position. The touchscreen alternates between the x and y position, sensing alternately applying the horizontal and vertical value gradients. So this is the cross section of the resistive touchscreen. Next we are going to see about alarm clock. So in this alarm clock there is a requirements. So this requirements alarm clock front panel should be like this. So this is the requirement table. So name, purpose, input and output functions, the performance and manufacturing cost, power and physical size and weight. So by using this requirement form, we can design the alarm clock. So this is the class diagram for the alarm clock. So there is a lights, display and mechanism, button, speaker. So this is the details of lower level class of the alarm clock. So in this lights, button, speaker, display and classes under variable functions are the digital value, digital scan and alarm on light, PM light. So this comes under lights. Then button, set time, set alarm, alarm on, alarm off, minute and hour. So under the speaker there is a buzzer. Then under the display class there is a time for integer, alarm indicator, boolean, PM indicator. So these boolean indicator and the alarm indicators are PM indicator and alarm indicators are boolean values. So under the set time there is an alarm light on, alarm light off and PM light on and PM light off. So this is a state diagram of update the timer. So update the seconds in clock with rollover. Update the hour within the rollover. If it is AM, then the PM is true as AM rollover. Whether the PM is false or true. So PM is true means display set time, current time. Current time greater than or equal to alarm on time and on the switch on the alarm buzzer. Then compute the button activities. So alarm on, alarm off and set time and non-set alarm and minutes, set time and non-set alarm and hours. So these several classes are used to set the alarm clock value. So next one is component design and testing. The two major software components, interrupt handle and the foreground code, can be implemented relatively straightforwardly. Since most of the functionality of the interrupt handle in the interrupt process itself, the code best tested on the microprocessor platform, the foreground code can be more easily tested on the PC workstation used for code development. So coming to system integration and testing, because the system has a very small number of components, system integration is relatively easy. The software must be checked to ensure that the debugging code has turned off or not. The three types of tests can be performed. First, the clock accuracy on the clock checked against the reference clock. Second, the commands can be accessed from the buttons. Finally, the buzzer's functionality should be verified. Thank you.